Okay, Michael, so that was a great conversation. What have we learned?
All right. Well, we talked about ensemble learning, which was the idea of instead of just learning one thing, if it's good to learn once, it's even better to learn multiple times.
And
Uh,
in multiple ways.
the simple version that we concentrated on first was this notion of bagging, where what we did is instead of just learning on the whole data set, we would subsample a bunch of examples from the training set different ways and train up different classifiers or different learners on each of those and then merge them together with the average.
Okay, so if I can summarize that, we learned that ensembles are good. We learned that even simple ensembles, like bagging, are good.
We talked about the fact that by using this kind of ensemble approach, you can take simple learners or simple classifiers and merge them together and get more complicated classifiers.
Yeah, so we can take combining simple gives you complex. Anything else?
And we talked about the idea of boosting, where you can, oh, maybe this is why it's called boosting. You can take something that has possibly very high error, but always less than a half, and turn it into something that has very low error.
So we learned that boosting is really good. And we talked a little bit about why. That's good. By the way, there's a whole bunch of other details here too, right? Boosting also has as does bagging. Not only has these little properties you've talked about before, but it tends to be very fast. It's agnostic to the learner. Did you notice that at no time did we say try to take advantage of what the actual learner was doing, just that it was in fact a weak learner?
Mm.
So I think that's important. It's agnostic.
Meaning you can plug in any learner you want.
Yeah, so long as it's a weak learner. So there's something we learned
Okay.
about. We learned about weak learners. Yeah, we defined what that meant. And we also talked about what error really, really means with respect to some kind of underlying distribution. What do you think, Michael?
That seems like useful stuff.
These are useful stuff to me. I'm going to throw one more thing at you, Michael, before I let you go. Okay, you ready?
Yep.
Here's a simple fact about boosting that turns out in practice. You know our favorite little overfitting example? Remember how overfitting works? You have a training line that tends to get better and better and better, maybe even going down to zero error. But then you have test error, which gets better and better and better, and then at some point starts to get worse.
Mm.
And at that point, you have overfitting. And I think, Michael, you asserted at some point, or maybe I asserted, that you always have to worry about overfitting. Overfitting is just a kind of fact of life. You got to come up with ways to deal with it, of sort of overbelieving your data. Well, what if I told you that in practice, when you run boosting, even as you run it over time, so that your training error keeps getting better and better and better and better, it also turns out that your testing error keeps getting better and better and better and better and better and better and better.
That seems too good to be true.
It does seem too good to be true. It turns out it's not too good to be true, and I have an explanation for it.
Tell me.
Not until next time.
Oh, all right. See you
All
then.
right. See you then. Bye.